All right, in this video, we're actually going to continue on in chapter 9, which is the lesson itself is fairly straightforward, but you'll see some of the problems require you to, simplify your radicals, use distance formula, and of course, use the quadratic inequality. So if you haven't watched the other video yet, you might get stuck on example 3. All right, so like I said, this lesson is fairly straightforward. So if you remember the Pythagorean theorem, right? Basically, the Pythagorean theorem states that if triangle ABC is a right triangle, then you can say, hey, c squared is equal to a squared plus b squared, right? That was the Pythagorean theorem. The way I like to say it is the hypotenuse squared is the sum of the two legs squared, okay? Because this could be any letter, this could be any letter, this could be any letter. Okay, so converse, right, just kind of switches that statement up. So instead of saying if it's a right triangle, then c squared is equal to a squared plus b squared, you could say, if c squared is equal to a squared plus b squared, right? If this is true, then you can say triangle ABC is a right triangle. Okay, so really that's just the converse, right? Converse just means switch this statement with this statement, right? Okay, so that would be the converse of the Pythagorean theorem. Or you can think about, hey, if the hypotenuse squared is the sum of the two legs squared, then ABC is a right triangle. All right, so there's a couple of other theorems that are very, very much similar and related to it. So over here, again, this is little c, right? Little c is the side of the opposite of angle C, the big C. These are all lowercase letters, and these are uppercase letters to refer to the angles. So if I say if c squared is less than a squared plus b squared, right? I have an inequality symbol. Then I can say triangle ABC is an acute triangle. Okay, so if the hypotenuse squared is less than the sum of the two legs squared, right? Actually, we no longer call this the hypotenuse. We call it if the longest side squared is the sum of the two legs squared, then we can say that ABC is an acute triangle. Okay, and then of course, here's my last, again, what's an acute triangle before we move on? Acute triangle is a triangle who has all angles that are acute, and angles that are acute are between 0 and 90 degrees. Okay, so last possibility is if the longest side squared is greater than the sum of the two sides squared, then I can say triangle ABC is an obtuse triangle. Okay, so the concept is, like I said, very, very straightforward. You just need to practice a lot of your algebra, distance formula, and of course the quadratic inequality, which we'll get to. Okay, so let's start with example 1 here on the back. Decide whether the numbers can represent the side lengths of a triangle. If they can, classify the triangle as right, acute, or obtuse. So let's take a look over here. The first thing I want to do is take a look at 3 square root of 5. 3 square root of 5 is approximately, if I enter this on the calculator, approximately 6.7. And so I know this is the longest side, right? The first thing I want to do is figure out if I can form a right triangle, if I can form a triangle, right? So if you remember your triangle inequality theorem, which states that, hey, there's 2 plus 6, is it greater than 6.7, which it is 2 plus, 6.7, is it greater than 6, and that looks like it is. And last but not least, right, 6 plus 6.7, right, which is my 3 root 5, that's also greater than 2. So yes, I could form a triangle, right? So if I can form a triangle, now I have to classify it as right, acute, or obtuse. All right, so how do I do that? I'm going to take my longest side right here, which is 6.7, and I'm just going to square it. And I'm also going to take my 2 here, I'm also going to square it. And I'm going to add it, okay? All right, why am I squaring this? And why am I putting it here on the left side? Because this is the longest side, okay? All right, so this right side right here should not be difficult, right? This is just going to be 4 plus 36. Now, when I square a radical with a coefficient, okay, so this is just a quick recall. A to the nth, AB quantity raised to the nth is A to the n, B to the nth. That means when I square this, I have to square the 3, which will give me 9. I also have to square the root 5. Root 5 squared is not 25, right? It's just 5. Okay, so how did you get that? Let me just show you really quickly. 3 root 5 quantity squared is 3 root 5 times 3 root 5, right? 3 times 3 is 9. Root 5 times root 5 is root 25. 9 times 5 is just going to be 45. Okay, so notice this is a lot of work, right? But in the future, you could just square the 3 in your head, square the root 5 in your head. That's just 5. 9 times 5 is 45. Okay, so lots of algebra skills that you need to practice here. But if you could just do it in your head and say, hey, this is 9 times 5, which is 45, that's perfectly valid. Okay, so notice I didn't write anything here because I don't know what the final expression is. It going to be equal? Is it going to be less? Or is it going to be greater? Okay, so 4 plus 36, that's 40. And this number right here, right, which was the longest side, is bigger than 40, right? So that means c squared is greater than a squared plus b squared, right? This is a, this is b. Then I can say that this is an obtuse triangle. Okay? And that's pretty much what you're doing for all the remaining types of problems in B and C. All right, so take a look at part B right here, right? 15 plus 20, I have to justify if it's even going to form a triangle. And right off the bat, right, 35 is not bigger than 36, so I can't form a triangle. Okay, so remember the triangle inequality theorem, right? The sum of two sides must be bigger than the third side. I don't have to do 20 plus 36 is bigger than 15. As soon as I arrive at a contradiction, I can stop. So I'm going to move on to the very last problem, part C here. Again, I would use a calculator to, figure out what 7 square root of 5 is. Approximately 7 square root of 5. That's about 15.6. So this is clearly the longest side. That's the only reason why I'm using a calculator, is to see that, hey, is this number bigger than this number? So I know to isolate this, okay? All right, so just like I did on the previous problem, I'm going to isolate 7 root 5. I'm going to square it, leave a little space here, square my 7, and square my 14, add these two guys, right? So if you take a calculator, square the 14, I believe you're going to get 196. And this time I'm just going to show you the work here in my head. I'm going to do the work in my head. 7 squared is 49. Root 5 squared is just 5. Okay, so again, I don't need to show all this work here on the side again. I showed you why that is. When you multiply 49 times 5, I believe you get 245. 49 plus 196, you're also going to get, I think, 245. Now you take a look, right? These numbers equal each other. So again, this is my C, this is my A, my B. C squared is equal to A squared plus B squared. Therefore, I have a right triangle. Okay. Okay, so last example on this page. Decide whether the triangle is acute, right, or obtuse. Again, you're using the same concept, except this time the letters are kind of different. So the concept doesn't change, right? Don't always memorize it in terms of C squared, A squared, B squared, but just memorize it in terms of the longest side, right? So this would probably be the longest side if I were to estimate, right, if everything was drawn to scale. Let's call this BC, AC, and AB would be the legs. So how do I determine if it's acute, right, or obtuse? Well, if BC squared, right, is greater than AC squared plus AB squared, then of course I know that, if this guy, the longest side, is greater than the sum of the two other sides, then I know this is an obtuse triangle, right? If BC squared is equal, right, to AC squared plus AB squared, I know it's right. And of course, if BC squared is less than AC squared plus AB squared. I know this is acute. Okay, so it's the same concept except the letters are arranged differently, right? So if I call this angle C, this would be little c. If I call this angle B, this would be little b. If I call this angle A, this would be little a, and then you would have A squared is equal to B squared plus C squared. So don't get too confused by, you know, the lettering. It doesn't really matter what the letters are. It's just think of it in terms of the hypotenuse, or rather the longest side. Okay, that's what you're comparing. The longest side squared. Is it greater than, is it equal, or is it less than the sum of the other two sides squared? Okay, so some of you probably already know what to do, right? I need to use distance formula to compute all these side lengths. And so let's quickly review using our distance formula what the side length of AC is, AB and BC. Okay, so AC is the square root of, you know, x2 minus x1 squared. So we'll do -2 minus -5 squared plus 4 minus -2 squared. Okay, -2 minus -5, that's going to give you 3. 3 squared is 9. 4 minus -2, that's 6. That's 36. That will give you the square root of 45. Okay, so I know what you're thinking, right? At this point, you want to simplify your radical. You don't want to do that because later on, what we're going to do is we're going to take AC and we're going to square it, right? So when we square my AC length, the square root of 45 squared is just 45. So you don't really need to simplify, okay? And you'll see why in a minute. Do the same thing for AB. Find the distance between here and here. -2 minus 6 squared plus 4 minus 0 squared. All right, -2 minus 6 squared, that's going to give you 8. Sorry, -8. -8 squared is 64. 4 squared is 16, and you're going to get the square root of 80. Okay, so again, you could simplify this, right? This is 16 times 5, which is 4 root 5. But you don't want to do that because we're going to be squaring this in a minute. All right, so last but not least, we need to calculate the length of BC. And BC would be 6 minus -5 squared plus 0 minus -2 squared. Okay, 0 minus -2 squared. Okay, in case you didn't see that, 6 minus -5 squared is 0 minus -2 squared. Okay, so a little bit of mental math. 6 minus -5 is 11. 11 squared is 121. Positive 2 squared is 4, and you get the square root of 125. Okay, so clearly this is the longest side, right? Whatever number is the biggest inside the radical is the longest. So this is the reason why I don't want to simplify all my radicals, because what I'm going to do right now is I'm going to take root 125, right? This is the longest side. I'm going to square it. And these two guys I'm going to square and add. Right? And take a look. When I square root, right, it's just the argument itself. Whatever's inside is called the argument. If I square root, it's just 45. 80 square root squared is just 80. And you're going to get 125 is equal to 125. Therefore, it's a right triangle. Right? Why is it a right triangle? Because what I did over here was I said BC squared is equal to AC squared plus AB squared. Okay, so I'm not going to do another example, right, to determine if it's acute or obtuse. It just depends on the problem. Okay, so you're using the same concept, comparing the longest side squared. If it's greater than, it's obtuse. If the longer side squared is equal to the sum of the other two sides squared, it's right. And if the longest side is less than the sum of the other two sides squared, it's acute, right? So sometimes might not be useful to memorize it in terms of C squared equals A squared plus B squared, because the A and B and C, the little a, B, and C would be different in this problem, okay?